Okay, so prove by contradiction that for any integer n squared minus 2 is not divisible by 4. So let's suppose not. Suppose not. Get rid of my little underline so I can save myself some room. So for any integer means there exists an integer such that n squared minus 2 is divisible by 4. Okay, so let's go do it. How can I show n squared minus 2 is divisible by 4? I'm thinking if I want to talk about any integer, right? There's no way I can pull a 4 out of that, but let's do the cases. Let's do the case where I'm talking evens and odds. Let's see if that works. So this is kind of, how do you come up with this bright idea, right? Well, when you can't think of a way of dividing through by 4 on an expression, and you're wanting to show that it is divisible by 4, think of breaking your n down into different forms, and we could do odds and evens, that's d equal 2, or we could do d equal 3, which is d equal 3k, 3k plus 1, or 3k plus 2. So it's when you're kind of backed up against a wall of how can I express these integers that you come up with the bright idea of the cases. All right, so let's do n equal 2k. So again, start with your expression, then substitute it in. And I should say k is an element of the integers, right? So then I get 4k squared minus 2. And what I want to show is that this is divisible. I want to show that this is divisible by 4, right? So I want to show that this is equal to 4k. And I'll say k is an element of the integers. So this is equal to 4k. The right-hand side. So this is me showing n squared minus 2 can be written, it is going to be divisible by 4. All right, so let's do 4k squared minus, oh dear, I used k in 2 places, didn't I? Oh, that's very bad. Very, very, very bad. Okay, so let's do t here, right? Can't use k's in 2 places. So let's do t on this right-hand side. So 4t. So if I have n equal 2k, then put t on this side. Okay, so then let's subtract the 4t and then add the 2. Okay. Oh, does this look familiar? Whoops. I'm trying to factor out the 4 here. Factor out the 4. So then I get k squared minus t is equal to, right, 2 over 4 or 1/2. K is an integer, so that means k squared is an integer, t is an integer, it's equal to 1/2. It should be an integer, right? So should be an integer. So there's my contradiction. Remember, I'm trying to show that this contradiction is false. So this is false for the case of n equal 2k. So when you're doing the cases, let me erase this so I can make myself some room. I need to use the other case when n is odd, right? Because I'm splitting all numbers up to either be even or odd. So now you want to tell your reader, I'm doing the case now when n equal 2k plus 1. And what I'm trying to show is n squared minus 2 is equal to 4t, right? T an element of the integers. And here I know k is the element of the integers. Okay, so that has to be stated, right? Because I'm going to need that in the end. So let's put in 2k plus 1. So then you're going to need to multiply this out. Okay, so let's pull everything that has a 4 on the left-hand side. And then pull these 2 on the other side. So it'll give me a positive 1 over there. So I factor the 4 out. So I get this integer, k squared plus k minus t, equaling 1/4. And that's my contradiction, because this should be an integer. And you don't have to state every time that addition, subtraction, and multiplication of integers gives me integers. It just should be. All right. Now here is the other method of proof. The other method of proof is contraposition. Okay, so first we want to make sure we state it as it is. So make sure we explicitly write for every x and d, if p then q. Sorry, I should have put these on the next line. Then I want to write it as the contraposition. So remember what the contraposition is? So you negate this, but that's the if, not this, then not this. So if this is false, then this is false. And then this, if I can show this is true, then that must mean this is true. So there's no showing anything's false, but sometimes it's useful to go in the other direction with the negations. All right, so here we go. So prove by contraposition, and I'll tell you how to do the proof. If 5 does not divide n squared, then 5 does not divide n. Ooh, okay, so let's rewrite this first. So for any n in the integers, comma, right? If 5 does not divide n squared, that's how we write that. Put the divides thing and put a line through it this way. Then 5 does not divide n. So there's not usefulness when there's the does not divide. So let's write the contraposition. So the contraposition will be for any n in the integers, comma, if the negation of this, so if 5 does divide n, then the negation of this, 5 divides n squared. So then we just move forward through the proof. So 5 divides n means n is equal to 5k, where k is an element of the integers. And now I'm going to square both sides. So n squared, 5k squared. So that's 25k squared. Tried to write that. 25k squared. That's n squared. So what am I trying to show? I'm trying to get to that 5 divides n squared. So just to formally write it, this shows that 5 divides n squared, because I've showed there's a factor of 5 to pull out.